JD.
So we're going to look at signs, like negative or positive, sign rules for addition, multiplication, etc. We're going to look at operations. We're going to look at order of operations. Then we're going to look at decimal notation, and then we're going to look at operations with decimals. So here are some sign rules. So for addition and subtraction, they're kind of similar. With subtraction, you can just change it to addition by subtracting the opposite. So with addition, if the signs are the same, that means that they're going in the same direction. So a positive plus a positive equals a positive. You would add those two numbers together and keep the sign. If the signs are different, like one is positive, the other one's negative, they're going two separate directions, two different directions. You take the difference of the two, larger minus the smaller, and then you would take the sign of the larger number. Now, the sign rules for multiplication division are easier. If the signs are the same, you get a positive result. So if it's negative times a negative, or negative divided by a negative, it would be positive. If the signs are different, then it's going to be negative. So if they're unlike signs, one is positive, the other one's negative, then the result is negative. All right, so here's example number 1. We're going to look at addition. So if I look at 7 plus 3, those are both positive. So they're both going the same direction. So I'm going to add them together, and I get 10. If I look at the second one, which is 3 plus negative 7, the signs are different. So I take the difference of the two. 7 minus 3 is 4. The sign of the larger one is negative, so it would be a negative 4. Negative 3 plus 7, again, the signs are different, so it's going to be 4. But this time, the 7 is positive, and that's the larger number out of the two. And I know that positive numbers are always larger than negative numbers, so you kind of, when asking that question, you ignore the sign. So 7 is positive, so the result is going to be a positive 4. The fourth one, negative 7 plus negative 3, the signs are the same, so they're going in the same direction. You would add the two and keep the sign, so it would be a negative 10. 7 plus 0, or anything plus 0, is just that number, so it would be 7. And then negative 7 plus 7, they're opposites of one another, so that would give you a 0. Now you can also, when you're doing additions, subtraction, you can think money. So if you start off with $7, you gain $3. You have more money now, so you have $10. If I look at 3 plus negative 7, you have $3. You lose $7. You're now in debt $4. Start off with a banking account with negative 3. You gain 7. So now you're in the positive. You have 4. All right, so now let's look at subtraction. Now, what you can do with subtraction is change subtraction to addition, and the way that you do that is by adding the opposite. So I can change 5 minus 6 to 5 plus negative 6, adding the opposite. Now, then once you do that, it changes to addition, then you can apply the sign rules for addition. Get negative 1, because they're different signs, take the difference of the two, keep the one that's larger. Here you have 6 minus 5. I think you know you can do that. 6 take away 5, you end up with 1. But just to show you, you can change subtraction to adding the opposite. So it becomes 6 plus negative 5. Apply the sign rules. The difference of the two is 1. Keep the sign of the larger number, which would be 6, so it would be a positive 1. Now this is, so you have 5 minus negative 6. You can change that to addition by adding the opposite. The opposite of negative 6 is a positive 6. So you can rewrite that as 5 plus 6. So that'd be 11. And then with that last one there, negative 5 minus 6, you can change it again. You can also think money, so you're in debt $5, you lose $6, you now are in the hole of 11. So you're in debt $11. All right, so now let's look at multiplication. Now multiplication and division are going to have the same sign rules. So when it's the same sign, it's positive. When they're unlike signs, it's negative. And you do the operation first, and then you look at the sign afterwards. So 6 times 6 is 36, and it'll be positive because the signs are the same. Negative 5 times negative 5 is 25, and it'll be positive because the signs are the same. Negative 18 times 5 is going to be 90, and it's going to be a negative 90 because one is negative, the other one's positive. They're unlike signs, so it's a negative result. 1 times anything is just the anything. So here it will be 1,754. Now anything times 0 is going to give you 0. So now let's look at division, and the rules are the same. So 36 divided by 36 is 1, because 36 goes into 36 once. And it'll be a positive 1 because both those are positive. 21 divided by negative 3, 3 goes into 21 7 times. And since the signs are different, it's going to be a negative 7. The fraction bar, I'm introducing it here, but the fraction bar is the same as division. So negative 19 over 1 is the same as negative 19 divided by 1. That's going to give you 19, because when you divide anything by 1, you just get the anything. So it's going to be negative 19. Negative 18 divided by negative 3. This one right here. Since the signs are the same, it's going to be a positive result. Again, you're ignoring that until the end. So 18 divided by 3 is 6. And it would be a positive 6 since the signs are the same. 51 divided by 0 is, because you're asking how many times does 0 go in 51 when you're dividing, and that doesn't make any sense. So it's what's called undefined. And undefined just means that you cannot define it. And a way to remember this is a word with no. So NO spells no, and when it's no, it's undefined. So any number divided by 0, including 0, it would be undefined. Now, what about the other case where you have 0 divided by 13? Well, that's like saying you have 0 donuts, and you can have 13 people and you're dividing it by 13 people. Each person gets 0 donuts. Not the most favorable examples. But anyways, so 0 divided by some number is going to give you 0, always. Unless you're dividing by 0, that's when it's undefined. So, but you can remember this by 0 divided by n, which spells on. So it's A-OK on, where undefined is no way Jose undefined. On is OK 0. All right, so now I'm going to introduce some other operations. So here, absolute value. When you have absolute value, think distance. So the absolute value of 14, that's 14 units away. So that would be 14. Think distance. Distance is always positive because you're just asking for how far it is away from something. So the absolute value of 0 is 0 because you haven't gone anywhere. Now the absolute value of negative 14, you're still 14 units away, so it would be a positive 14. Negative 5 is 5 units away, so that would be 5. So that's how absolute value works. It's just think distance. Now let's look at exponents or powers. Now 5 squared, when it's a power that 2, tells you how many times 5, which is the base, that you're multiplying that by. So here 5 squared, or 5 raised to the second power, is 5 times itself twice. So 5 times 5, which gives you 25. You can also think of it, the exponent is a shortcut for multiplication. So that's 25. Negative 5 squared is saying the same thing, or negative 5 raised to the second is saying the same thing. So it would be negative 5 times negative 5, which gives you a positive 25. Letter C is a little tricky, that's why I throw it in here. Because what you're doing, you're actually squaring the number first. We'll go into a little bit of order of operations. So you're squaring the 5 first, and that negative in front acts like a negative 1. So it would be negative 1 and then 5 times 5. So look at the difference between B and C, and notice that the negative 5 for letter B is inside the parentheses. So that tells you what you're multiplying together, those number of times, is negative 5. Where with letter C, the 2 is only attached to the 5. So only there the 5 is being squared. And a negative just comes along for the ride. So it would be 5 times 5, which is 25 times negative 1, which would be negative 25. Letter D, negative 5 raised to the 4th. It's saying the same thing. So it would be negative 5 times itself 4 times. You can kind of ignore the signs because if the exponent or the power is even, it's always going to be positive. And here 5 times 5 is 25 times another 5 is 125 times another 5 is 625. Negative 5 cubed would be negative 5 times itself 3 times. And that will give you negative 125. Because the exponent is odd, whatever the sign is, it retains its sign. So if you start off with just a positive number, it will be positive. If you start off with a negative, it will be negative. So order of operations, you're probably familiar with it. PEMDAS, please excuse my dearest Aunt Sally. I do not have an Aunt Sally. You might have an Aunt Sally, but it's just a way to remember it, or you can remember it as PEMDAS. I think we have a lawyer in the area and where I live called PEMDAS. But anyways, Oh, and I switched the, I did that. I switched the M and the D. That's interesting. The key thing with order of operations, and you can kind of see here, I grouped, you have parentheses, exponents, and then it's multiplication or division from left to right, and then addition or subtraction from left to right. So, and I'll go over order of operations again in another unit. But here, let me just show you the order of operations. Now, there is a certain level of flexibility with order of operations. So even if you don't do it rigidly, you want to be careful. So I'm just going to do the order of operations as is, but again, there's a certain level of flexibility. So sometimes you can get away with doing things slightly out of order. Sometimes, not all the time. So PEMDAS, please excuse my dearest Aunt Sally, parentheses or grouping symbols, exponents, multiplication or division from left to right, and then it's addition or subtraction from left to right. So think about it in 4 steps as opposed to 6, because the multiplication and division go together, and then also addition or subtraction go together. All right, so notice what I did first. I'm doing the parentheses, the 50. So we have, let me back up a little bit. So that's negative 3 squared plus 36 divided by 9, parentheses 52 minus 25 times 2, close parentheses, open parentheses, negative 4, close parentheses, squared. Now, with order of operations like this, also your calculator can do the work for you. So, but anyways, just I'm going to show you how to do the order of operations. So, because you'll need to know it in some other places. So first you do what's inside the parentheses, and when you do what's inside the parentheses, order of operations follow. So you would have to do multiplication first, which is 25 times 2, and then subtract. So 52 minus 50 is 2. Then you have, you simplify the parentheses. This parenthesis right here and this parenthesis, this is holding the sign, so it's a negative 4 that you're squaring. Also here, the parentheses are indicating multiplication. So you want to do exponents next. So negative 3 squared, only the 3 is being squared, so that's why it's 9, and that negative comes along for the ride. Here it's a little different, so negative 4 squared, that's negative 4 times negative 4, which is 16. And be consistent. So in the next line, it's still multiplication since it's right next to the parenthesis with the 2. So then you want to do multiplication or division from left to right. So I'm going to do 36 divided by 9, which is 4. And then 4 times 2. This is all multiplication, so I can actually switch the order, but I'm going to do it kind of rigidly. So 4 times 2 is 8 times 16. 8 times 16 is 128. And then negative 9 plus 128 is 119. So order of operations is parentheses. Everything in the parentheses, order of operations applies. So you want to do multiplication first, or division, and then addition, subtraction. Then once you have all the parentheses done, do the exponents. Once the exponents are done, do multiplication or division from left to right, and then addition or subtraction from left to right after you finish all the multiplication and division. All right, so now let's look at decimals. decimal notation. And what's important with decimal notation is place value. Oh, this is just an overview of decimals. So we're going to go over place value and rounding, getting ahead of myself. Addition, subtraction, multiplication, and then division. We're going to look at the operations with decimals. But first, we're going to look at place value and rounding. So again, like I said, place value with decimals, our numbering system, the position where it's at is very important. The position tells you the value, hence place value. Distinguishing mark is the decimal. The decimal separates the whole numbers, I guess you can say, the ones, tens, hundreds, and then the decimals. These are in fractions. Again, I'm just showing you this so that you can kind of see the pattern. So you have tenths, hundredths, thousandths, 10,000ths, 100,000ths. So again, the place where you have the value and the determining mark of those larger than one or larger, or less than one is the decimal. All right, so how would you write this as this number as a name? And I'm going to show you how to do this properly instead of 1788.045. You can do that, but it's going to be helpful with fractions to know how to pronounce it mathematically, I guess you could say. So the determining mark is the decimal, and that separates the whole part from the those place values that are less than 1, tens, hundreds, thousands. And the way that you pronounce it is you want to look at the place where it ends at. So here, that 5, you have tenths, hundreds, thousands. That 5 is in the thousands place. So you have 1,788. The decimal you replace with and then how to pronounce the other portion of the decimal is you would say the number as is, but you would end with the place value where it's at. So it would be 45 thousandths because that 5 is in the thousands place. So my example numbers are off, but I'm going to continue. So we're going to look at different ways to round 3,872 and 2,459 10,000ths. So letter A. If you want to round to the thousands place, you look at 10,000ths. If it's 5 or larger, you round up in the thousands place. Now, when you round, it's either going to stay where it's at, that number, or it's going to go up. So here it's going to go up, and so it becomes, that 5 becomes a 6. In the thousands place, let's look at letter B. Here that you're rounding the hundreds place, so you look at the thousands place where the 5 is at. That would tell you that you round up, so that 4 would become a 5 in the hundreds place. Nearest 10, that 10, since it's not tenths, it's going to be larger. It's going to be in the tens place, as opposed to the tens place on the other side of the decimal. So you want to look at the ones place, which is 2, which would indicate that you round down. Now when you round down here, that number 7 in the tens place stays the same, but you have to put a 0 in there, again, because place value in our numbering system is very important. We don't use pictures like Egyptian numbers. Well, ancient Egypt. So anyways, with letter D, it's the hundreds place, right? It's not hundredths, so it's a hundreds place. So we're going to look at the tens place, which is 7. That 7, since it's 5 or larger, would indicate in the hundreds place that we round up, becoming 3,900. So that's how you would round. Now let's look at the operation. So let's start with addition. Now with both addition and subtraction, it's important that you line up the decimal. Again, key to place value, because once you line up the decimal, that lines up all the place values: ones, tens, tenths, hundreds, thousands. And then you would just add, once you have those place values or the decimal lined up. Sometimes you might want to put zeros in there just so that you can have everything lined up nicely. 0 plus 7 plus 0 is 7. Yeah, line up the decimal. 7, nothing to carry. So then it would be 2 plus 3 plus 0, which is 5. 4 plus 2 plus 1 is 7. Decimal stays in the same spot. 3 plus 0 plus 4 is 7. And then just 1 is 1. So that would be 17 and 757 thousandths. All right, so now let's subtract. Looks like some work is already there. It's always larger minus the smaller when you're doing this. So you always put the larger on top, the smaller one on the bottom. The sign rules apply, so you ignore put the larger minus the smaller, and then worry about the sign rules at the end. But it is a difference, so you will be subtracting. All right, so you have 8 minus 0, which is 8. Now you have 2 minus 9, you're going to have to borrow or regroup. So you borrow, yeah, so you would have to, you have 2, so you're going to have to borrow. So you look at the next place value to the left, nothing's there. So then you look at 5, so you have to borrow from the ones place. So then that 0 will become a 9. You're dropping things off. So this is, you have 5, you're taking a 1, you're splitting that up. That 1 becomes tenths, and you have 10 tenths. So you drop off 9. And that tenth becomes 10 hundredths, and you're adding that to the 2, which then becomes a 12. So it's 12 minus 9. You can kind of remember that if whenever you have a 0 in between, you have to drop off. It becomes a 9. So you always do that in between, where with the place value that you need, you add 10 to whatever number that is. So it'd be 12 minus 9, which is 3. 9 minus 0 is 9. Then you have this one right here. I guess I'm borrowing and I skipped a step there. So it's 14 minus 7, which is 7. So that would be 7 and 938 thousandths. All right, example number 7 is multiplication. When it comes to multiplication, you don't necessarily have to line up the decimal. What you want to do is line up the digits. So here you have, and I'm going to go a little faster here. You're going to do 3 times 148. With the decimals, ignore until the very end. So 3 times 148 is 444. And then 9, since it's one place value over, use a 0 as a spacer. So 9 times 148 is 1,332. Put the 0 there as a place value. Then you would add those together. 4 plus 0 is 4. 4 plus 2 is 6. 4 plus 3 is 7. 3 and then 1. Then the place value just count. So 1, 2. So that'd be 2. So your final answer is 137 and 64 hundredths. You can do a rough estimate. So I can do 150. So this is 15. I'm rounding, and I'm going to round to 10 to make it easier. So 15 times 10 is going to give me about 150. So you can use estimation as a way of checking, but you can also do all this on your calculator. All right, so let me show you division. So 517 and 2/10 divided by 6. With the decimal, when you're doing long division, you just bring it to the top. 6 goes into 51. Well, 6 doesn't go into 5. Then you go over to 51. It does 8 times. 8 times 6 is 48. Then where you're doing long division, you subtract. So 51 minus 48 gives you 3. Bring down the 7. How many times does 6 go into 37? 6 times. 6 times 6 is 36. Subtract the difference between those, 37 and 36, you get 1. Bring down the 2. 6 goes into 12 twice, and it goes into it evenly. 12 minus 12 is 0. So my final answer is 86 and 2/10. So here it's slightly different. Now we're dividing by decimal. And what you would do first is you would change whatever you're dividing by, which is your divisor, and what you're dividing into is your dividend. Those are going to come up later. I'm just mentioning those now. So you're going to move the decimal place over once, which is make it 48. And whatever you do over here, you do over here. So you would also move the decimal place over once with the dividend. So that would be 48. And that becomes the 4.824 becomes 48.24. How many times does 48 go into 48? 4 into 4, none. So you do 48. Does go into it once. So 1 times 48 is 48. Subtract the difference. Bring down 2. Does 48 go into 2? No. So it'd be 0. So bring down to 4. Does 48 go into 24? No. So it'd be 0. Bring down the 0. Does 48 go into 240? Yes, 5 times. and it goes into it evenly. So 240 minus 240 is 0. So 1 and 5 thousandths would be my answer. So, foreseeing the future, and there's going to be fractions in the future. And so let's do a little division here. 3 divided by 8. 8 cannot go into 3, so 8 does go into 30. Now, kind of look at it, you see that 3 over 8 looks less than 1. And again, we're going to look at fractions next unit, but I'm just giving you like a little foretaste so that you can see the relationship between decimals and fractions, and then fractions and division. So 3 over 8 is the same as 3 divided by 8. So we're going to see how many times does 8 go into 3. It doesn't, but 8 does go into 30 3 times. And notice that you just bring up the decimal just like before. 3 times 8 is 24. Subtract 30 minus 24 is 6. Bring down 0. That's 60. Does 8 go into 60? Yes, 7 times. 7 times 8 is 56. 60 minus 56 is 4. Bring down 0. Does 8 go into 40? Yes, 5 times. 5 times 8 is 40. 40 minus 40 is 0. That's it, you stop. So my final answer is 375 thousandths. And I'm okay with you saying 0.375. Whatever is more convenient, but I'm saying that when it comes to pronouncing it correctly, that's going to help you convert a decimal into a fraction. All right, so there are different types of decimals. You can have a terminating decimal and a repeating decimal. There's also non-repeating and non-terminating, but we're not going to go over those. Might see those in the future, but we'll see. So terminating decimal just means it ends. So here's some examples. 0.5, all those end. Then you have what are repeating decimals. Repeating decimals, they never end and they repeat. They just go on and on and on and on and on. Okay, you get it. I'm repeating it myself. Anyways, so there are decimals that repeat. So like 0.33333, 0.636363, and sometimes represented by a line over it. So whenever you have a line over those digits, that tells you that those digits repeat. So if it was just over the 3, 3 would repeat. Here, since it's both over the 6 and the 3, that means it's 0.636363. It just repeats. So we're going to look at fraction. Again, this is the same as dividing. So 7 divided by 11. We're going to get a decimal here. So 11 can't go into 7. Does it go into 70? Yes, 6 times. And again, when you're doing long division, the decimal just goes up in wherever place where it's at. So it does go into 6 times. 6 times 11 is 66. 70 minus 66 is 4. Bring down 0. 11 goes into 40 3 times. 3 times 11 is 33. Subtract those. 7. Bring down 0. Does 11 go into 70? Yes. 6 times. 6 times 11 is 66. It's looking vaguely familiar. Subtract 70 minus 66, you get 4. Bring down to 0. Does 11 go into 40? Yes, 3 times, 33. I don't think I mentioned this before, but it's price or right rules when you're doing long division. As close as possible, but without going over. So 40 minus 33 is 7. Oh, there's a pattern there. It's repeating. I'm going to have to bring down 0 again, and then I'm going to get a 6. And then it's so once you see that there's a pattern and it's repeating, you can just stop. So it would be 0.63 repeating, or 63 hundredths repeating. So how do you round repeating decimals? You can extend it. So 0.05, if I round to nearest tenth, I just need the hundredths place. And that would indicate rounding up. So it would round up to 1/10. You can extend a little further from doing the hundredths place. So if I'm rounding the hundredths place, then I want to look to the thousands place, and so that 5 would indicate rounding up, so it would be 0.6 or 6 hundredths. Same extension, but I can go to the 10,000ths place. That tells me to round up, so that's how I got 56 thousandths. So you do the same thing. You repeat as much as you need to get that place value that you need, right to the right of it, and then you can round up or round down. You just extend it as much as you need. So with this next one, which is 0.47 repeating, if I'm rounding to the tenths, I only need up to the hundredths place. So that 7 would indicate rounding up to 0.5. Kind of repeat a little bit. I only need the thousandths place. That 4 would indicate rounding down to, so it's a 7. So that'd be 0.47 hundredths. Same amount here. I need the 10,000ths place. So I only need to go to the 10,000ths place. The 7 would indicate rounding up in the thousands place. So the thousands number 4 becomes a 5. Now with this last one, since it goes all the way up to 10 thousandths, I can just use that. So 1 would indicate rounding down, so that'd be 7 tenths. That 4 in the thousands place indicates rounding down, so the 1 would stay where it's at. That's in the hundredths place, so it's 71 hundredths. And so that's 71 hundredths. And then the 2 would in the 10,000ths place indicates rounding down. So that 4 would stay the same as well as everything else. So that'd be 714 thousandths. Now, what if you have something like this? You can round to make things easier. You can also just do this in your calculator, but let me show you how you would do this by estimation. So I have about how many Blu-ray discs at $29.99 each can be purchased for $154. So you can approximate the $29.99 to $30, and I can round down to the $154 to $150. So that gives me about 5 discs. So I can check that, see if I don't go over my budget. So I can do on my calculator 5 times $29.99, and that gives me $149.95. And I did not go over. Now, with everything that we gone over, you can do all these in your calculator. So I would try to do it by hand first, and then just check yourself in the on the calculator, and don't let these, just try to do your best in here in these sections. But you can just use your calculator. But it would be good to some degree, especially with integers, positive or negative whole numbers, to try to do those without a calculator. All right, so what did we go over? We went over as far as decimals are concerned. We went over other operations with whole numbers and integers, like the sign rules and things like that. Now for decimals, we went over place value and rounding. We went over addition and subtraction, where you have to line up the decimal. Multiplying decimals, you would line up the digits and then multiply just like you would multiply in long multiplication, but you take the decimals at the end. Dividing with decimals, we looked at that, where it's just you divide using long division, and you might have to adjust the decimal, but when you're calculating, and the decimal just moves up on that division bar. And then we looked at repeating and determining decimals. And
thank you for taking the time to watch this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful day.